In today's session, we'll discuss primarily regarding the programming aspect of blockchain. There are various platforms on which we do programming. One of the most important aspect that allows us to create a lot of decentralized applications is Ethereum. There are many of others that are coming up, and there are different stacks that we can use it up. But in today's session, we'll primarily use Ethereum. And it is not that we are just learning a particular language. We're also trying to learn how to learn a particular language, how a problem is solved using particular language. And as we have seen in many other fields like advocate or like doctors, they all keep on evolving, keep on learning, but they have learned how a disease can be cured. And as soon as a newer type of disease or newer type of symptoms comes across, they know where to refer, they know where to look up, and the basics is very, very strong. So in this aspect, in this session, we'll primarily try to learn more about the programming part of blockchain. Where does it impact and how can we start learning from it? The most important aspect, we'll be using two of our resources. One of them is Ethereum Solidity docs, where most of our application development would be using Solidity. And Ethereum naturally uses Solidity as a programming language, but we will also be using JavaScript as well, primarily because if you're doing and writing some test codes, so JavaScript allows us to write them in a faster way. And Solidity sometimes at odd times becomes a bit too cumbersome to write them up. So we'll be referring this Solidity document as soon as we are learning to make sure that whatever we are learning, we are also referring the correct source of it. And also we will refer this particular IDE. We will be using Remix. You can also set up your own local host. You can also set up your own Ganache and different nodes as well to test up the system. But we'll try to use in this particular session Remix. It's an online version to test the working of the test codes. And we'll start working with the how does a basic and simple blockchains basic codes start working on it. Fine. Okay, now Ethereum. We know that what is Ethereum. We know that how it works. So before starting programming, we should also know what are the aspects of it that we are using in it. In contrast to Bitcoin or a Bitcoin blockchain network, which uses the concept of the transactions to verify each other, and each transaction verifies each other. In Ethereum, we have a concept of account-based ledger, where every account has a particular system. We have a balance for an account, we have a public key and a private key. So now, without worrying too much about how proof of work works and how mining works, I will start working across to Solidity part, how we can use this particular combination to start working across and start building up some solutions that we will explore in this particular session. Since it may be the first session for you, you are learning this programming language. So I will try to make sure that we are learning the correct way, learning slowly. And it is important for you to be comfortable with not knowing everything right away. So don't try to be comfortable with each and every terminology that you are hearing should be very clear right away. As soon as you will be learning or hearing them 2 or 3 or 4 times over this particular session, maybe practicing after this particular class as well, you will get more and more comfortable as well. Right? Initially, in the first class, it is not important for a person to know that what is 1, what is A, what is B. But as soon as it is getting in the terminology of a particular way, we can see that 1 + 1 is equal to 2 and 3 and 4 and so on and so forth. Right? Let's start diving deep into Solidity programming. Okay, what are smart contracts? So because in Solidity, we need to, why is a programming language required? A programming language in Ethereum is necessarily required to run smart contracts. And as we know that smart contracts are the codes which run automatically in the sense that when we tell that something to run and the condition is satisfied, they can perform the tasks for us. And these smart contracts are the very important components of blockchain, which allow us to give various different scenarios and run them on their own. Now, you may have a question, sir, in a general Java program or in a general Python program, they can also be called as smart contracts, isn't it? They're also having same functions. They're also having same if-else loops. They're also having different condition is met. Different things are being made as well. We have our applications, mobile applications. They run different type of programs as well, isn't it? Now, your question is perfectly valid as well. But for that to understand for you that what works in a smart contract and what is the domain and range and length and breadth of it. One of the important aspects of the smart contract is that it is first of all known to everyone, that whatever we are writing in the smart contract, it's not that there is an application which is maybe an Amazon.com or a Google Pay. Nobody knows how it works at the back end. But smart contract, you can look at it, whatever can be exposed, what are the rules, regulations, and nobody has a different higher or lower superiority than running, than even the person who has deployed it as well. This is the first difference to start with. But there are other very, very significant and architectural differences that we know of that are different from the ones that we know of in the traditional ones. To be starting with it in the very first class, it will be very highly generalization, but we can generalize that as the programs are there in cloud, or as the programs are there in native centralized server application, we can at least for this particular session think of it as the smart contracts which run in a decentralized platform where we call right away Ethereum. And Ethereum has a set of different nodes that automatically have their own consensus mechanism. I won't be going too much into depth of that, but at least you can think of that. And like any program that is running either in a centralized place or a decentralized place, some incentive needs to be given. Somebody needs to make sure that how and who are running all this computation, getting into consensus. They have their own machine setup, initial cost. They have their own processing that is done, so electricity is powered on. They have their own cooling system to be made sure. So that that energy that is consumed by the validating nodes in the Ethereum network, that is taken away by us when we are writing the smart contracts in the form of a gas that we'll use. More about gas and other things as we go across the theory part of this blockchain very soon. Okay, now let me just ask you a few questions. Anyone would like to ask something, say something? Somedi, Yash, Amit, you all three of us right now.
So, sir, basically, I just want to know that as a blockchain developer, we need to know JavaScript and Solidity both to. Okay.
So it depends upon the end goal of it. If you are thinking about, I want to become a cricketer, should I be fine with having a bat and ball and going to the playground and playing 2-3 times? Do I want to play at the gully cricket level? Do you want to play at club cricket level? Do you want to play at national level? Do you want to play at international level? Or want to become #1 cricketer? So it depends upon what is the final goal. At least to start with it, at least you should have a bat and ball, and you should have significant amount of good enthusiasm to go to the field. Start playing something with a lot of enthusiasm. And yes, at the end goal of it, at the back end for it, yes, you can say that. And when we are working in Ethereum type of programming language, having a good initial experience of JavaScript is a bit helpful. But that's not all in all. When we are working on the back end of it, even in the programming of blockchain, we not only will use Solidity, we use JavaScript, but there is also a front-end component of it as well. And for that, we use React and Redux as well. And that's only one set of a stack that we are consuming and that we are considering. There are other stacks as well, for which programming language like Rust would also be very helpful. But it's also very important for us to know that whether one particular programming language or other, we should not be tied up to it. To start with it, yes, having some sort of a basic introductory experience of Solidity and how we learn would be fine to have the backend covered for the decentralized application built on Ethereum set of or Solidity set of base languages.
Right. Thank you, sir.
Anyone else? Or are we good to go? Yes, Somedi?
So nothing right now. I joined a bit late actually.
You joined just in time.
Me too, sir.
Yes, thank you so much. Let's start building upon it. And as soon as there are some questions, some doubts, I will try to make sure that within the end of this session, your most of the doubts are clarified. Your most of the doubts are clear. While you're going home, at least you have good set of takeaways and some sort of things to get inspired to implement right away after this session. But understand, blockchain is one of the important programming platforms that can solve a particular problem. So entire idea is how we can solve some problems. Blockchain provides a set of technological fundamentals that allow us to solve some problems that were difficult to solve in other ways around. And for that, we are creating some sort of applications that can allow us to solve those problems. And one of them is we can develop on Ethereum. And to create decentralized application, or in simple way applications. We are learning how to do that in this first introductory class where we are learning how Solidity. Right. Okay. Now, as every programming language, we all have been born and brought up talking some languages. We are also conversing in English, isn't it? We are able to talk to each other because we know English. It's a medium for which we understand. When I'm speaking something, your mind translates it. And if I tell you to do something, and if you have a good amount of rapport and you feel that I am in good of your interest, you may try to act upon that. At least you will understand what I am saying. Similarly, to talk to a particular platform that is blockchain, we need to understand that that particular platform, how does it understand, in what particular way should I speak, or to communicate properly, they will act on that way. So that particular programming platform, which we say that Ethereum, that understands some structure. And when we are building upon that structure, it is very easy for us that there is no communication gap. And generally, communication gap happens when we try to say something and the Ethereum platform says, no, I don't understand, or go about it. There is an error, or there is a segmentation fault, as we have seen in C programming languages. But when you try to say something and the program doesn't even execute, or executes and does something different than what we want it to do. So it is important for us to understand that how does the other platform understand what is their world, what is their system. Right? With this particular base, we are trying to learn a language which allows to communicate with the other person. So if you both of any two of you are communicating and you don't have any single common language to talk to each other, maybe let's say somebody talks in Bengali and Yogesh understands only, hypothetically speaking, Japanese. Hypothetically speaking, now both of them, neither Somidip understands Japanese, neither Yogesh understands Bengali. What to do? Either of them have to learn each other's language. That is the only way, and they have to talk to each other somehow or other. So that is how we can't expect Solidity or the Ethereum platform to understand English, but at least we are intelligent persons. We can understand how that particular platform can be talked to or communicated to. So in this entire Solidity structure, we know that in the first language, you need to talk to that what version we are using, because there are different versions that keep on coming and evolving, and every version it was a different thing in Java that we had initially in 1994, 95. Then some updates kept on coming, and then Java 11 and something they are coming. But understand that in last 30 plus years, if I can 25 plus years, we have how many versions? Less than 15 versions, less than 12 versions. Even if we consider intermediates .1 something like that. But Solidity, how many years have passed and how many versions have come across? That's how dynamic this programming language is. That's how the changes are being made. And it may be possible that something that was working previously is not working now at all. And they try to make sure that it's not as systematically built as in Java, that it is not backward compatible. Some programs that were running in Java, let's say 5, are also running in Java now as well. Most of them, but here it may be a complete catastrophe if you are not putting the version correctly as well sometimes. So initially we have to tell the platform what version we are working with it. Then we need to tell the contract name. Understanding that you all understand some programming language, contract name is a contract which is in our language we can think of it as a smart contract. We can think of it as what this particular program will do for us. This is a name we need to give. And there are certain data types we need to use. After that, there is a constructor. Constructor means as soon as the contract is created or a new variable is created or it is called, that constructor will be executed. Then there are functions and there are a bunch of different stuffs that this particular program can do or a contract can do. Right? For this is somebody coming ahead and talking to in Japanese that this is a particular structure doesn't make any sense to us at all. That what you are saying, okay, tell me something which I can relate to it right now. Tell me something which I can relate to it, some existing programming language which I already know of it. So version may be similar to what version you are already familiar of what programming language you're using. The contract name, maybe you can think of it as the entire name of the program that you are writing, and in between different functions are the functions or methods that you may call in different programming language. Constructor, data types are data types. So we don't have to stretch too much that we are learning Bengali and we're learning Japanese, which is completely a different paradigm. We might already be knowing some programming language, whether it be C as well. So for us, data types are similar as data types in this. Only thing change we may need to have, what data types are accepted here. And the more important part of us is why are we learning data types? What is the fact? Because data types are a way in which we can think of what can be given and what operation can be performed by those data types. And if you perform such operations, what can we expect that in between it can happen? As simple as that. If you're talking about strings, what is that we can pass it on to a data type called string? If I'm using unsigned integer, what can we expect? And so on and so forth as well. So this is a very crude way in which I talked about a very simple structure. There are more to that in this particular platform. We can emit something and we can do something more as well. But this was some structure, and I will just give a pause here and allow you to ask many questions, allow you to speak up something. Did you understand? Did you not understand? What are your observations on this? Maybe Bhumit and others who have just joined. We are just trying to understand the programming paradigm, that is Solidity, which is important for us to create decentralized application on Ethereum platform that will allow us to solve some problems in real life. Anyone would like to say something? Comment upon something or whatever you can say. Or are we good to go?
We are good to go, sir.
Thank you so much. A couple of others have just joined in. Feel free to ask any questions. You all have full right, even if you have joined a bit late as well. Still, you have the right to learn and understand till the fact that you understand everything. Right? Okay. Now, this is some sort of a structure which we are considering. I request you, if you can open the remix.ethereum.org. I'm just sharing. Go to google.com and just type remix.ethereum.org. If you just click this particular tab, I'm not sure whether you're able to see what I typed, but at least just use remix.ethereum.org on Google. Give me a thumbs up if you're able to see this particular screen, something like that. This would be more of an interactive session.
Yes, sir, it is visible.
Yeah, if you are on mobile phone, or if you're not able to do something, or if you're driving, don't do that. But other ways, those who are on laptop or on a particular system, those who can try to program, at least try to be more interactive now. Fine. Now in this particular session, we'll be using Solidity as a platform. And now in this platform, we will try to create a new file to compile. And I think you need to create a first workspace. We call this workspace as blockchain programming. And the template we are considering as a blank right now, because default that may give up so many things. So now in this thing, they are given a bunch of Solidity files. We're not bothered about it that right now. Now we have created a workspace. Now we need to create a new file where we will start testing. Let's say we call it as new.sol. So whatever thing we are trying it up, whatever thing we are testing it up, we try to write it up and make sure that at the end of the day, even if something we are doing it, we are doing something hands-on. Just like if somebody is trying to understand Japanese, at least he would say the name, what somebody's name is. But at least he can say greetings to Yogesh. Right? In some interactive way, we'll start learning. Understand, it's a language we're understanding. The more you practice, the more you will be comfortable with it and use it as a weapon whenever you want to use it with you. Right? And it's a skill. It's not something which one can learn, what cannot learn. Just like everyone can learn cycling, like everyone can learn maybe riding a bike, everyone can learn swimming, and everyone can learn this language as well. It's a skill, it's a system. If you follow that system, if you be in that system, no reason you cannot learn that. Right? Okay, now most of you might have seen this interface. Can you say how many of you are able to see this interface? Till now, how many of you have been in here?
I'm there, sir.
I am also there, sir.
Great. Yogesh, Sakshi, Somidi, you can.
Yes, it is visible, sir.
I can wait and help you out if something is there. You may be required to log in or create something as well. Somidi, Sakshi, are you there? Have you created?
Sir, I'm hiding, so
No,
attending
no,
on
don't do that. You keep on writing it up and make sure that you are driving safe and you are traveling. That's fine. Samiti, how about you? I think he has gone to learn Japanese. Okay, maybe. Yeah, yes, you were speaking something. I think you can type it up. If something is required, I am not able to hear you right now. Uh,
Hello, sir. Can you hear me
but
right now?
yes, Samiti.
Yeah,
I am able
sorry,
to hear.
sir. The connectivity issues was very bad. I couldn't hear you for the last minute or something. Can you just?
I am just asking you, are you seeing this particular screen that is in front of
Yeah,
you?
yeah, yes, sir. Yes. Sorry, sir.
That's great, fine. Now let us go back to it. What we are trying to learn here. So this is a very basic program that we are trying to learn. Most of you might already be familiar with it, but still, as a programming practice, we are trying to learn Solidity. Right? So here, what can you think of it? What is there written? At least we can understand it's a version. We don't understand what is upper cap. Is it a raised to power thing? Is it what is it upper cap? But at least we can understand that it is upper cap, something that means we have to do with something with a version. Right? And there is a keyword written contract, and after that there is a written token. So I can understand the contract name for it, maybe called as a token smart contract. Let's go ahead. The first line of it says UINT public. Even if you don't understand what is public, even if you don't understand what is UINT, that's almost fine. But what we can understand is a data type that we are defining some variable, and we have defined that this is a variable we will be using in this particular program. Now there is a constructor. It's again another thing that we are using here. Its constructor means whenever the smart contract is loaded, it will be executed, and it's the same variable that we are using here, and we are assigning initializing it to 10,000. Very simply, we are doing it up here. Now I am not asking you to go into what is raised to power, whatever something. And as we understand in any programming language or any general language as natural language, when we say greetings, it's okay to say initially hi, even if you don't know what is the meaning of hi. It's okay to say my name is Amit and whatever your name is. Slowly, you will understand what is the meaning of the word my name is. So it's important to get excited and start using something. Slowly, you'll understand what does it actually mean. But this entire program means that we are using a programming language called Solidity. We are creating a smart contract and just initializing that variable whenever the smart contract is loaded with some value 10,000. Let's go back to our Ethereum console and try to write this program now. Now, this is the first thing that we write, pragma, and we write Solidity, what exactly we are using. So, and then we are writing a version of it. Now, in the version, we may write 0.8 point, whatever version we are comfortable with using. Let's say we are an old-fashioned person, 4. That is fine. So this is what we have just created. And I request if you can keep on typing with me, that that would be a bit helpful. Are you able to see this, whatever I am typing?
Yes, sir.
Great. Now just type something. Don't worry, even if it is spellingly correct and compiles or not compiles. Whatever best you can do right now, that is fine. Your intention is more important right here. Right? Now, what is the next part? We want to define a contract, isn't it? So we have defined now what version we are using. Let's start building with it. We want to define a contract. The keyword here is, it's fine. And let's try to give the name of the contract. Let's say token here. Let's try to be same thing what we have done. Now, this is the opening and closing part of the contract, and we have just created a basic skeleton of it. That yes, this is work. Fine. I may be slightly go 1 or 2 steps ahead. Try to follow up with me, so that once everything is done, I will try to make sure that we are compiling and running it up. Okay. Now let us start writing basic part of it. Let's define a variable UINT, and we define this variable UINT public. we will come back to it. What is uint mean? What is public mean? But let's say we define something, and we define another variable that's name is tokens. I think that's pretty basic. And now we define a constructor here. And basically we are defining a constructor, and what needs to happen in constructor? We're just initializing the value of this token. That's it. So now this is only thing that we are doing, and I will just copy it up. Not now, just I will allow you to, if you can practice up, type it up yourself. We're just defining pragma solidity. We are doing something. We are defining the contract name token. We are defining the data type of uint to a variable. We're defining a constructor. That's it. We're doing just simple basic things now. Fine. While you are typing, I will try to help you out to understand what does it mean line by line. And as soon as we are building it up, compiling it up, I will try to keep on speaking what does it mean. Okay? So now while compiling, this is the icon that you will be seeing on the left hand side. There is something made and there is something written here as well. So let us try to work with it and try to compile this file. It works okay, but it may give some error that SPX license something. We're not putting it up on chain right now. That's fine, but it's a warning that we can still work with it. And this Solidity is the Solidity we are using. The version means that upper cap means we are using all the versions above this. And if you can understand that we are using 0.8.7 and we are using 0.8.4, that's fine. Till the time we are using 0.8 point something, that's okay. That's acceptable. So this version 0.8.4, 0.8.5, 0.8.6, 8.7, 8.8, 8.9, all of them are acceptable. So we're running on Ethereum compiler, which is 0.8.7, and that is more than fine for us. Right? We're defining a contract. Contract's name is token, and we are defining tokens, and there is a constructor here. Right? Constructor means this token's value will be initialized as soon as the contract is executed. So let us try to deploy this contract and start working with it. We're not publishing an IPS or anything. Leave it right now, everything here. Try to work on this particular column. I hope you're able to see this now. On the left hand side, there is something which famously we know of on various icons that has become like a similar one for Ethereum or same name. But click this icon now and see what you are seeing here as well. Here we are seeing an environment. See what are the various environments which we are seeing. That is fine for us. We are only working on a test network. That's fine. This is an account number. We'll soon use this account number. Any of them we can use. Basically, what Remix is providing a test network with 10 different nodes. And our node is this one where we are trying to run this particular contract. And the gas limit for running this particular smart contract is something that is also defined for us. We will come to it. What is gas limit? We'll come to it. What is all these things, but basically you can understand that the program can run till the time there is some computation that is defined. So gas limit is similar to amount of computation we can run upon in this particular program. Okay, let us try to deploy this now and see what does it say. Okay, something has happened here, and there is a tick mark that I can understand in my mind. That means something positive, and it says from some address is given, and I think this address is similar to something, this one. And when I understand, oh, it is exactly the same as this one. So somebody tried to do something from this particular address, and 2 is also written. 2 is written, that means token dot constructor. Something is written, and somebody from this particular address tried to do something on this particular thing, and the value right now is 0. Okay, I may try to understand a bit more on this, and I will try to maximize it and start to understand it. And it says status is true. That means for me, true means it is a bit of a positive feeling. And now this is transaction hash, and other things are too much for us to do right now. Only thing for us to understand is there is a tick mark, green tick mark, and that's fine for me to understand. Fine. Are all of you till here? Anyone has faced any errors or something, would like to say something? Something is not working?
No, sir. We are there with you.
Thank
Yes,
you.
sir. Same case here.
You are able to run this, and you have seen a green tick here.
Yes,
Yes,
sir.
sir.
Oh wow, nice, nice. That's exciting to hear. First time you have done it. Maybe you are a super fast learner, and I assume that you will maintain the same enthusiasm continuing further as well. Okay, now we have deployed this contract. Now let us try to run this contract a bit more. What can we do with this particular contract? I think there is nothing we can do right now, and I can see that there is something save thing is there. There is something it can say. There is a keyword tokens. I have heard this word keyword. So, oh, this is the same as this one. So I can check out that what is the value of tokens. If I click here, can I? Let us try to click it here. Oh my God, that is the same as the same which we have initialized with it. So now I can understand that this may be a variable which I can access it from outside the smart contract as well. But how can I do that? Now I remember this word public that allows me means this particular chain that we're running to access the value of a variable that is inside this particular smart contract as well. So now understand public means that once that contract is deployed, then anyone can access at least the value of it from outside the smart contract as well. Great, that's nice. And there is something called as callback, but because we have not done anything for it, even if we do something, we might not be able to transact anything with it. So call data we might not be do. The maximum that can happen right now is it may put up some error, and we are fine with it. That's okay. There is an error. Call data should be very hexadecimal value. That's okay. If I even put some hexadecimal value, that may give out something. But right now, that's okay. That's okay for us to begin with it. We have done something. Something means we have written a contract. We have run this contract. We have deployed this contract as well on a test network, and we have seen that the value of tokens has been updated. So far, so good, everyone. Anyone would like to say something now? The others who are not able to compile because they are not right now in the system or traveling, that is fine. You can please ask many questions. Any question, I would be happy to have you. Yes, please. Yes, no need to raise hand. Just open the mic.
Sir, I had a question. Here it showed that it was costing something. This gas that was being costing, that the transaction cost in terms of gas. So what is this cost exactly, and who is paying for it right now? Because we are not paying for it right now.
Yes, very good question. Yes, thank you so much. So right now, where Yash is saying there is gas involved, let us try to understand where is gas involved. And now, if I go towards it, yes, there is some gas involved in it. Some gas involved. What is this gas here? Gas is something the amount of payment I need to make it up to run this contract in the main network also. So right now in the test network, just like the thing that if we have an Android application and on the local network, if I run it up, I'm not giving anything. But as soon as I put it up on AWS or any other particular cloud server platform, I need to know how much amount of if I'm using a model which is payment per amount of computation I need to do. So that is something of a gas. Here, gas means how much computation I have consumed. The higher the gas consumed means higher the amount of computation I have taken it up on the Ethereum network. Now here, I am not paying here because I'm in the test network. But as soon as I will deploy it on the main network, then I need to pay for it. For every time I need to deploy it up on the main network, this gas. And how will I pay with this gas? I need to purchase some currency which can be used to buy gas. And right now, Ethereum has its own native currency. So we will use that native currency to buy that gas to run that every time when you're using this smart contract to deploy it up. So this is the gas that is used to deploy the contract on the chain. That's it. We are not consuming anything. If you think of that as well. Right now, we're not paying it up because it's just a test network. It's a small thing that is working on this test network. But when we are actually deploying it on the main network, then we will have to pay for it.
So if I understood that correctly, sir, so if we want to execute this piece of code, we need gas, right? To execute this piece of code on actual network, right?
Actual means in the blockchain. So
Yes.
so now Amit has deployed some smart contract which says that some computation if else loop, and now you deploy it on smart contract and you want that Sakshi, Somadip, Yogesh, and Yash should be able to access it up as well and do something from it. Now, for that, you need to deploy it on the main network that is visible to everyone. So every time when you deploy, put something on the main network, that time you need to have that much amount of currency in the form of gas to do that.
Right. Only at the time of deployment, not at the time of execution, right?
I mean, if I understand, execution means you're deploying. If you're considering execution, that is execution. But if you consider that up here, if you're just searching something here, we haven't done something. For searching, I don't see any gas being consumed. Right? So if anyone is just searching it up, it's not. So why is gas consumed? Because Ethereum network is a state-based machine. State means not Uttar Pradesh, Madhya Pradesh state. State means there is a set of variables, there is a set of existing system that is working on Ethereum. As soon as we deploy something, state changes from state A to state B. Now, whenever state is changing in the Ethereum network, that time we need to have a consensus in the entire Ethereum network that yes, everyone should agree, all the nodes you should agree and should be visible to everyone that state has changed. For that, we need to pull it up. But for searching, no state has changed. So we don't need to consume or pay any gas.
Right. Okay. Thanks.
Yes, have I answered you somewhat? Or do you have any counter question?
Yes, sir.
I mean,
No,
just to
sir.
answer,
My
just to
question
have a
has been
counter
answered. Thank you.
question. Others, Sakshi, somebody, one of the others have just joined in. We are just trying to learn a programming language, Solidity, which is allowing us to create some applications on Ethereum network. And when we are creating some application on Ethereum network, we are trying to solve something using blockchain technology. That is a basic overall idea which we are considering. So one you may ask something as soon as you have got some grasp of what is going on. Is it fine?
Yes, sir. I just wanted to know that in which language is this being taught?
Good. So we are using Solidity language.
Okay, sir.
Solidity.
Okay. Because actually, sir, I forgot. I've placed my alarm, but I forgot to join at that time.
No issue. That's perfectly fine. Thank you so much. Okay. So now let us try to play with it a bit. I could have gone ahead and discussed many other components of programming or we can play around with it a bit. Let's try to play around a bit with it. Let us try to make sure that we try to do something with tokens as well. Okay, you can do it separately as well. But how should we go? Let's try to play something around it where we can give some input value. We can test it around that something. We can do it in something. Let us try to create some functions. And using these functions, we will try to play with this code. Right now, this code is not interactive. Right now, we have just deployed it somewhere. And right now, we have just got something that, okay, we have done something. Fine. Let us try to run something a bit more and understand what we are going ahead. So basically, we have used unsigned integer type, and there are different types of unsigned integers. We can use strings, we can use addresses, we can use many other things as well. That's perfectly fine. And there are other data structures we can use. We can use arrays, we can use mappings, and so on and so forth. We will try to understand them as and when we are using. We can also have events as well that can emit something and put it in the log file as well. So if something happens, we can write it up in the log file and somebody can look at the log file. Okay, this thing has happened, so I can take some action as well. So log files are something that whenever you enter into your office or whenever you enter into wherever any organization you're working in or you may be working in. So there is some attendance system. And the attendance system is generally visible to one or two persons who are either maybe having the authority, or if it is a hard copy based, maybe seeing who has entered just now. But here is a Solidity. They have given a log files where log file is visible to everyone in the Ethereum network. And looking at the log files, other smart contracts can also take some action as well. So when we want to write something in the log file, it is called as an emit an event. And emitting an event is nothing very simply, but just putting something in the log files. That's it. They have given a fancy name, emit event. Looks like cool as well. So then nothing to worry too much if you don't understand anything. But just remember that there is some concept of data types, some concept of the data structures. We can also use something called as mapping. We can also do something that is called as event. When we'll use it up, everything will come out to a particular perfect story, and we will be able to relate to it. And there are special variables, and that's okay. That's okay. Fine. Now it's too much for us to understand. I mean, suddenly you have come from 4 lines to 10 lines, 20 lines. Just hold on. That's okay. That's okay. Now that we are doing something here, we are trying to understand some structure here, and hold on for a moment or so. Allow me something to understand. After this 2 minutes of my speech, you'll feel a bit more relaxed. Don't start giving negative signals from your brain that it's too difficult or I'm getting uncomfortable. Just relax. Right? And this we understand this particular line. We understand that we are using particular version of Solidity. This is a smart contract, and understand this is something called as an address, where it's also a variable, but its data type is address. That's it. So which can store a variable of whenever we are passing an address. So in Ethereum, generally address is 160 bits or 20 bytes. So this address can store 160 bits of some data. Now there is a mapping. I will show you what is the mapping. But in mapping, it's just like if you pass on an address, it will return something, and something is here UINT. We'll come back to it, balances and associative arrays and something. Just understand it's a data structure right now. Now it's an event. We are just telling that there is an event called as send. We're not defining what is the event, just only declaring that there is an event, and event's name is sent. And what you can expect in the event, you can expect some initial part which is of an address data type, second part which is again of address data type, third part which is of unsigned integer data type. That's it. There is a constructor which we have just seen in the previous program as well. Nothing so fancy about it. Here we are assigning this data type minter with message.sender, and msg.sender is the address of the person who is calling this particular smart contract. So there are two different types of given or inbuilt variables that we can use. One of them is message.sender. So whoever has deployed this smart contract, its address is given in message.sender, and that address is initially assigned to minter. Now there is a function, something new we have seen. Function is the name that is given mint. It accepts first one data type of address, and another input variable is amount. So there is a function. It accepts two things. One is an address, and second is an amount. And it's of again public data type. Somebody else from outside can also call it. Here it's required. It's again one sort of an assertion. Only when it is true, this statement is true, it will execute. Otherwise, it will throw a type of an error. We'll discuss about what are the different errors, but it will stop then and there itself if message.sender is not equal to minter, and it will say no, no, I want progress further, crash or output error. I mean, just don't proceed further anything here in this particular program. There is some logic that is going on, and there is another function which is called named as send, and something also goes across, and something else is also part of it. Then there is a balances, which is something, and we have emitted an event as well. If everything successfully works, we have emitted another event that yes, write in the log file that something has happened. Fine. So I won't expect you to write everything here, but you understand the gist of it, that we have tried to use a lot of different components of this particular programming language. We have tried to use data types. We have tried to use data structures in the form of mapping. We have tried to use events as well, constructor, functions. We have tried to use assertions. And I think I don't want to make some dish which is called in Indian khichdi that you don't try to make any meaning out of it. But I hope there is a system to it. We have a procedure for making a perfect chocolate cake for you, where we have put up some basic ingredients in a particular structure, in a particular format, and everything has a particular way to put it up. And the different ingredients for this particular chocolate cake, if you can take an analogy of this particular program, where the recipes include ingredients are, we need to define the program, a programming compiler, we need to define, we need to use some sort of a token, we need to have data types, we can also use data structures, we can also emit events, declare them up, use constructor, use function, use assertions, and finally, in a particular order, if they are put it in a particular time when they are put it, it will create a particular favorite dish that you may relation up as well. Right? So now I won't stop here, but I will just show you here what you can play with it, so that you can also practice these aspects here as well. So here, instead of tokens, you can also create addresses as another data type. Take it as an exercise. Create something of not only uncertain integer, create something of addresses data type. Address data, sorry. You can also create something called as an event. You can write something here. Let's say, so maybe I define something here. We can declare an event, emit, and do something here. So try it many things as well. User sessions, and perhaps you can do something more as well when you're using. But since it is already 7:23, I need to give you a lot of time to ask many questions, try to understand, and you have something to take it up. At least after this particular session, all of you must be at least be able to write this particular program, play with different data types, and I hope that once you come back here, at least this particular thing you would have played with up whatever we have at least practiced today. Right? Now over to all of you. If you have many questions, I'll be very happy to answer. Yes, please, one shot. Don't raise hand. Just directly ask.
So here the msg.sender, is it a data type or any inbuilt function kind of thing?
It's an inbuilt special variable basically. It gives out the value of a particular transaction, and sorry, the address of transactions, who is the sender of it. So for example, if who is calling this particular smart contract, so that particular value, it's inbuilt that you can access it up using message.sender. For example, if you go to a particular room or a particular organization, in organization you may have a particular ID you have that is assigned to you. You have your own particular department is assigned to you, but implicitly there are some things which are known within organization that you can tell something that will return some value as well. So this is something similar to that. That is inbuilt part of it. Every smart contract can use it as many times as you want, and the value returns is the address of transactions sender who is sending that particular transaction basically.